Hello guys, this is Teacher Medda. How are you? I'm feeling great. And one announcement I'd like to make before we proceed with our lesson is this chemistry class will be on air on every Thursdays instead of Wednesdays. Well, I'm very busy on Wednesdays actually. I got so many things to do, and sometimes I'm short of time to prepare the lesson properly. Whenever anybody works under, in a rush, there is always tendency to do mistakes. So I don't like to work in that manner. So I chose to do it on Thursday because I have some free time on Thursdays. So from now onwards, our chemistry lesson will be on Thursdays, right? So today's lesson, we will be still concentrating on electrolysis of a molten compound. Reason being, there are so many things actually you need to learn when you want to electrolyze the molten compound. Therefore, another week is necessary for you to understand the whole picture, and only next week we will be able to proceed with the electrolysis of an aqueous solution. Then again, that requires another couple of weeks. So today we will be learning how to predict products produced by electrolytes of a molten compound. Now, we are not only going to do experiments, we are only doing predictions. The chemists or the scientists have done all this for hundreds of years, so we don't have to repeat everything all over again. But when you go to your school lab and do some experiment, it's just teach you how to get used to working with apparatus and so on and so forth. But you don't have to do everything using a lab experiment. You don't have to do it by doing a lab experiment. So you can, after understanding the basic principle of electrolysis, whether it's a molten compound or aqueous solution, you will be able to predict what are the products that will be produced when electrolytes are being electrolyzed. Okay? So we will be learning about how to predict what products will be derived from a certain electrolysis. This is what we are going to do today. So in this manner, you need to use a lot of visualization, so a lot of brain power here, right? So a banana a day will give you some extra electrolytes, so that your neurons will move effectively from your brain, right, to your fingers or whatever. So let's proceed. Last week we learned how to conduct an experiment to prove that electrolysis of a molten ionic compound will produce different product, or breaking down the ionic compound to its basic constituents. So we have done that. We have learned how to set up the apparatus, then what are the materials we need to use, and then we have done the experiment and we have got the result. And from that experiment, we have electrolyzed molten ionic compound lead to bromide and produce two basic element, that is bromine gas and lead metal in solid form. So here you can see the diagram showing the same process, right? So in any electrolysis process, you definitely will need a pair of electrodes, an anode and a cathode, and you need an external electrical circuit, a battery or any other electrical power source. Then of course you need to heat the material or the ionic compound. Like in this case we use lead 2 bromide, so you need to heat them up to melt them into a molten state. So the moment they are in molten state, the ions will be moving freely. Now when you run through an electricity current through the electrodes, what will happen is all the anions will move and get attracted to the anode, while the cations will move and get attracted to the cathodes. So the moment they are there, what they will do is they will release electron. The ions will release the electrons. So the moment they release the electrons, the electron will be sucked up by the electrical current and pass to the cathode. So the moment an ion releases its electron, it changes form to become the basic element, and in this case it will become bromine, and 2 bromine will join up to become bromine gas. So you will produce a bromine gas in this experiment and in this electrolysis. Now at the same time, the lead ion at the cathode will receive the electrons from the cathode. So upon receiving the electrons, they themselves, right, will change form and get themselves discharged from the cathode and become a lead metal and settle down in the crucible, at the bottom of the crucible. So the process will go on for 10-15 minutes. So then you will collect all the bromine gas on the anode side and all the lead metal at the cathode side. So after the experiment, when you pour off the molten compound, you will find that lead metal is deposited at the bottom of the crucible. So that is what will happen in any electrolysis process. So here, by this you can predict the product of electrolysis of any molten electrolytes. So electrolysis of molten ionic compound produces metal at the cathode and non-metal at the anode, and the ionic compounds are decomposed into their respective constituents during the electrolysis. So that's how industries get all the substance they need to manufacture some other stuff, right, for benefit of mankind. Now we have discussed how soap are being made, how margarine are being made, and so on and so forth. So this is the same process. And then understanding this basic principle, you can predict the outcome of any electrolysis of a molten compound. Now you have seen how lead 2 bromide being electrolyzed and what are the products being produced. Likewise, if you're going to use a different ionic compound, say lead 2 oxide, what will it produce? So going through the same process, it surely will produce oxygen gas and lead metal. You don't have to do any experiment. You can just deduce that when lead 2 oxide is being electrolyzed, you definitely will get oxygen gas and lead metal. So oxygen gas will be released at the anode, and lead metal will be discharge at the cathode. Simple principle, only different materials. So let's have a look at the equation here. Electrolysis of molten lead 2 oxide PbO will produce lead at the cathode and oxygen at the anode. So since the ion move freely, you can observe here that this ion PbO in liquid form will split into lead with 2 positive charge and oxygen with 2 negative charge ions. So they are moving freely in the molten compound. Now at the cathode, when electricity is run through, the lead ion will receive 2 electrons. So when lead ion receives 2 electrons, so lead becomes a metal. So it becomes lead metal in solid form. Whereas at the anode, oxygen will release its 2 electron each. So 2 oxygen atom will release 4 electrons, right? So when they release 4 electrons, so this oxygen will join together to become oxygen gas, right? So from this equation, you will observe that at the cathode, molten lead is formed, while at the anode, oxygen gas is given off. So for the first half of the equation, you will see that Pb2 plus in liquid form will give off, receive 2 electrons, right, to become a lead metal, whereas at the anode, 2 oxygen will release 2 electrons each. So they release 4 electrons altogether, and they form to become oxygen gas, right? And oxygen gas is given off. So the overall equation, you will see that the 2 lead oxide in liquid form will produce 1 lead metal in solid form plus 2 oxygen molecule, which is released as gas. So the overall equation will be 2 PbO in liquid will form Pb in solid, 1 Pb in solid plus 2 O2s released as gas. So that is how you can predict ionic compound when they are ionized, when they are electrolyzed. So now let's go forward and see what happens if you were to electrolyze molten sodium bromide and ABr. So when you electrolyze NRBr and ABr, they will produce sodium at the cathode and bromine at the anode. So if you look at this equation here again, NABr in liquid form, right, will produce ions in a form of natrium with a positive charge and bromine with a negative charge, right? So when electricity is passed through at the cathode, what will happen is natrium will receive an electron and become solid. It become sodium metal in a solid form, and at the anode, 2 bromine, will release their electrons, right, and turn into bromine gas, So once a bromine release its negative charge, release its electron, the other two bromine will join up together to form bromine gas and given off at the anode. So this is what happened. So at the half equation, at the cathode, molten sodium is formed, whereas at the anode, bromine gas is given off. So the overall equation is 2 NaBr in liquid form will produce two products, that is 2 sodium molten sodium, and then 2 bromine molecule that is given off as gas. So this is what the result of electrolyzing sodium bromide. So you don't have to do any experiment. By just understanding the principle, you can split the ionic compound to produce the various products. In this case, to produce 2 molten natrium, sodium, or sodium, and 2 bromine atoms, right? So in conclusion, you can conclude that predicting the product of electrolysis of molten electrolyte using carbon electrodes are the same anywhere when you use carbon electrodes. Now we specifically say carbon electrodes because carbon being inert, they won't react with the chemical reaction happening in the electrolysis process. Although we may use some other metals as electrode for some other reason, for electroplating for instance. But for the moment, we can predict what are the products being produced when electrolyte has been molten electrolyte have been electrolyzed. So if we can assume that we will use this electrolyte, assuming this Mx, so if we use Mx as the electrolyte in molten form, we know that any electrolyte in molten form contains a mobile cations here and mobile anions, right? So these mobile anions will get attracted and move to the anode, whereas the mobile cations will get attracted and move to the cathode. So when electricity is passed through, that is where cation will be discharged at the cathode by gaining electrons, and anion will also be discharged by giving away their electrons, right? So by discharging themselves, an ion will change into a gas, whereas the cations would be discharged and become molten metal, right? So this is the process, one way through the cathode and the other through the anode. So when electrons are moving from the anode, you will get ions will get discharged and becomes gas, whereas cation, when they receive electrons from the cathode, they will get discharged and becomes a metal. So this is basically what the whole process is all about, and I'm pretty sure this visual can make you understand the process of electrolysis of a molten compound. So to test your understanding, can you predict the end product of this molten compound at both the carbon electrode? Now we have 4 compounds here: sodium chloride and NaCl, number 2 lead 2 iodide, PbL2, and number 3 copper 2 oxide, CuO, also known as copper oxide, and number 4 potassium bromide, that is KBr. So now all you need to do is just look at this formula: NaCl, PBI, CuO, and KBr. When you look at this, just refer to your periodic table. The moment you refer to your periodic table, then you definitely will be able to write the half equation of the reaction at both the electrodes. And of course, you will also will be able to determine the overall equation of the electrolysis of these particular electrolytes. Right? So now, look at sodium chloride. Number one, sodium chloride. Now, what is the product that will produce when sodium chloride is being electrolyzed? Right? You look up at the periodic table. You look for sodium, which is Na. That is group 1 period 3. And then you look for Cl, that is chlorine. Chlorine, which happens to be group 7 in period 3 as well. So when the moment you look at chlorine, you know chlorine happens to be in group 7. So when they are in group 7, they definitely have 7 electrons. So they just need only one to, you know, be in octet situation. They only need one. Whereas natrium, they have one valence electron. All they need to do is just release one for them to become noble, so to speak. So they will easily react. So what will happen when you melt sodium chloride? So you definitely will get natrium, sodium, molten sodium, and you will also get chlorine gas. So how are you going to write them? Right? So that you have to figure out. Likewise, you look at lead-2 iodide. So iodide is actually from iodine. So you want to look for iodine. Iodine is situated in period 5 in group 7. They are the same family of fluorine, chlorine, bromine. So iodine is at period 5. Whereas lead-2, lead is plumbum. So plumbum is at period 6. So although it is listed in group 4, right, meaning when they said group 4, they have 4 charges, right, positive charges, but lead is also found in having 2 charges. That's the reason why we call it lead-2, not lead-4. So lead can be lead-2 or lead-4. So in this particular, we are talking about lead-2. Now I'll explain to you this later. Then copper 2 oxide, again copper 2. Now copper, you have 2, you have 3, right? You can even have 1. So copper 1, copper 2, copper 3. So in this particular case, we have copper 2 oxide, right? Also known as CuO, or called cupric oxide. Then we have the potassium bromide, KBr. So the moment you look at this formula, I'm sure when you split them in 2, you know what you will get. Now all you need to do is just write the half equation of reaction at both electrodes, and then determine the overall equation of the electrolysis. Now if you can do this, then I'm pretty sure you can definitely pass all your exam in time to come. Right? So you have to do that. Now before we end this, I like to bring to your attention this what we call the Roman numerals. You know, Roman numerals are used to indicate if the metal has more than one charge. You know, some metals, example iron. We have iron with 2 positive charge, and we also have iron with 3 positive charge. While lead have 2 positive charge and 4 positive charge. So does zinc and copper. So which one are we referring? So that's the reason you have to be precise and write accordingly what are the specific metal are being used for the electrolysis, so that you can write and correctly. So you definitely will encounter metals having this kind of numerals, right? So they're just like, you know, like a stick, one, and here 2 sticks, here 3 sticks. This is IV, 1 and V. So this stands for 4. V alone is 5. Now V plus 1 will become 6. V plus 2 becomes 7. So never mind about that. So here you only need to be familiar with 1 stick like this, 2 sticks like this, 3 sticks like this, and 1 stick and V. So these are what we call the Roman numerals. So this is a symbol of number 1, this is 2, this is for 3, and this is for 4. So these numerals are used to indicate specifically which metal you are referring to. So you must write them correctly. So example, if you are given FeO, iron oxide, it's just written FeO. So which iron are you referring to? Iron with 2 positive charge, or iron with 3 positive charge? Which one are we referring to now? Since FeO is just written FeO, right? So to answer this question, you just have to refer to your periodic table, as simple as that. So you look at your periodic table, you look at Fe, and you look at O. Fe is iron, right? And O is oxygen. So where is O located? O is located in group 6, and we know pretty well all elements in group 6 have 6 electrons, and then they only require 2 electrons to achieve the octet status, correct? Right. So since oxygen having 2 negative charges, obviously when we talk about iron, we surely must be referring to the iron with a +2 charge, because when to balance oxygen which has 2 charge negative, you need an ion with a 2 plus charge, right? So then what do you get? You will get the formula as iron 2 oxide. That's all you need to understand. It's just as simple as that. So you just look through this again. Remember, when you are doing your writings, right, make sure to identify the element correctly. So you will need to use all the numerals, the Roman numerals to indicate, right? So let's go to the next one. Let's see what is the next one. Okay, this is lead chloride, PbCl. So if it's written as PbCl4, look at your periodic table. Pb stands for lead, plumbum, and Cl is chlorine. So now nothing is written on the Pb. We are not sure whether this Pb we are referring to Pb2 or Pb4. So now all you need to do is look at chlorine. So when you go to your periodic table, look at chlorine. You know chlorine is situated situated in group 7, they only need one electron, so they are only having one negative charge electron, right? They have one negative charge. So since we have in this formula 4 chlorine, so 4 chlorine will total up 4 negative charges. So that being the case, the lead has to be the one with a 4 positive charge. So just one lead with 4 positive charge is enough to get hooked up with 4 of this chlorine. So hence the formula is written as lead 4 chloride. So PbCl4 can also be written as lead 4 chloride. I hope you're very clear on this. Right? So to determine Pb, either is 2 or 4, all you need to do is refer to chlorine. So the moment you look at chlorine, you know chlorine having a single negative charge and having 4 chlorine in this formula. So definitely the lead is surely the one with having 4 positive charge. So you can conclude that the PbCl4 is actually lead 4 chloride. You can write it lead 4 chloride. 4 not in number 4 but IV. 4 in the form of IV, the Roman numerals. Okay, let's see another one. Okay, this is Cu2O, copper 2 or copper 1 oxide. Actually it's not written as copper 1 oxide, it's always written as Cu2O. Now copper 1 oxide is also known as cuprous oxide, right? Now in order for us to know which copper we are referring to, since we know copper have 3, copper with a single positive charge or with 2 positive charge, and copper with 3 positive charge. So which one are we referring actually? But since we are looking at CuO, we know O has 2 charge, two negative charge. We know O has 2 negative charge, right? And you only have 1 O in that formula. So since Cu, 2Cu is in the formula, 2Cu in the formula and 1 O, so you got nothing else to refer to except to refer to the copper with positive charge. So since O having 2 negative, all you need is 2 copper 1 charge, right, to balance what is oxygen. Hence the formula is written as copper 1 oxide. So copper 1 means we are using the copper with a single charge, a positive charge. So we are specific now that Cu copper oxide is copper 1 metal that is being used, right? So go through this again and again and understand, because it's not that difficult actually. Only don't get confused, just stay cool and you will do everything right. And I'm pretty sure in your exam you can easily write all the equation effortlessly. So now after this lesson, you know why Roman numerals are being used in writing chemical formulae. Okay, so until we meet again next week, as a reminder, do your assignment, break or electrolyze sodium chloride, copper oxide, and potassium bromide, and write down the half equation at both electrode as well as the overall equation. Now just do this and practice. As I said, if you can do this correctly, you can be a great chemist in no time. So then until we meet again next week to learn about the electrolysis of an aqueous solution, this is Teacher Matt Zai bidding you bye and see you again next week. Thank you for your time.